Maddie, Sini, Jessica, and I, Miller, had a vision to help get clean water to families in third world rural communities. The group decided that building a water filter specialized for a specific community would complete this vision. This filter would need to filter out all bacteria, chemicals, and most viruses present in the water. The group's main goal is to create an effective and cheap alternative to purifying water. Secondary goal is to get the working filter to that third world community.
Originally, our plan was to make a biosand filter. This filter is designed so that water would run through a biofilm on top, sand in the middle, and gravel on the bottom. When water passes through the biofilm layer, microorganisms eat and break down other bad bacteria.
Our initial timeline was to create a small-scale 5-gallon filter using gravel, sand, and dirt, with biomaterial film on top. Once this model was tested, we would move on to a large-scale 55-gallon container. Our cost for a single small-scale model was projected to be $90, as we planned to have gravel donated. The total budget for supplies was $220, but planned for about $1,000 because of making multiple models and breakage of parts. We met with our mentor, Dr. Jorge Loyo, in May of 2016 to introduce our design and implementation plans. Some of the main concerns we discussed was the fragility of the biofilm layer necessary for filtration and time to grow. It is for these reasons and the high cost of this proposed timeline that we shifted our project in a different direction.
Creating a functioning biolayer can take up to 6 months, and we did not have the time nor the resources to do this. Instead of doing a biosand filter, we created a different design consisting of ceramic filters and activated charcoal. After further trial and error, we finally came up with a 3-bucket design for our final product. The first section of the filter is the ceramic candles bolted to the bottom of the first bucket. As water passes through the 4 of those, it is purified. After it drips out of the ceramic candles and down into the second bucket, the water passes through a layer of activated carbon granules. The last step of filtration is when the water goes through a series of layers of chicken wiring and netting to get any glass impurities out. This layer also allows for a slower water flow and prevents the activated carbon from coming out of its layer and into the clean water chamber. To test our filter, we went to Rice University and met with our mentor, Dr. Jorge Loyo. He allowed us to use his equipment in the engineering design kitchen to measure pH, which is a measurement of the hydrogen ion concentration in a fluid, with most bottled water having a pH level ranging from 4.5 to 6.5. We also measured for turbidity, the cloudiness or haziness of a fluid caused by large numbers of individual particles that are generally invisible to the naked eye, coliform bacteria, a bacteria that when present in drinking water can pose health risks such as fever, cramps, and diarrhea. And lastly, we measured for E. coli, another form of bacteria that poses one of the major issues with the water available in Malawi. Diseases caused by E. coli include diarrhea, kidney failure, and urinary tract infections that can be fatal. The pH of the body water was 9.2, the turbidity measured in NTUs was 8.61, coliform bacteria colonies were present, and there were 11 E. coli per milliliter of water. After being filtered, the results showed that there was a significant decrease in all categories, and we concluded that the water was technically drinkable. The pH was in normal range at 7.5, the turbidity had gone down to 3.81 NTUs, and the filter had cleaned out all traces of bacteria. The water was also much more clear. These results prove that our filter was indeed effective and could be used as a filtration system in poor households.
The effectiveness of the design surprised the group. The water used in the trial run was collected from the local Buffalo Bayou close to Wilchester Drive. The group first tested the water for bacteria. The test showed that multiple colonies of E. coli and other various bacteria were present in the water. After testing the dirty water, the group ran it through the filter. The filtered water that came out was clear with no bacteria. This took about 12 hours to get a bucket full of filtered water. Though this takes long, the filter was effective in getting rid of the bacteria.
After our filter was functioning properly, our next step was beautifying it. To do this, we covered the ugly orange buckets with a spray-painted white coating. Since we knew exactly how to build the water filter now, we also wanted to figure out precisely how long it would take to build one of these filters without stopping. We disassembled our filter and reconstructed it. It took us about 2 hours to do this. Although this might seem slow, the process could be sped up with more people working or through the use of machines that were out of our budget range. Our final cost for building one filter was $205, including all the materials we bought that broke or did not work. If we did not make any errors, it would have cost only $135. This is a great number compared to our original budget.
Our team faced many challenges throughout this process. Changing design plans meant starting over from scratch, but in the long run allowed us to create and test what became a successful filter. The ceramic filters did not have a threading we could find a fitting for. Due to the brittleness of the plastic threads, this led to 2 of the candles breaking. With the help of Sheldon, we were able to create our own aluminum nut that screwed into the candle. We ourselves will most likely not be able to send our filter to Malawi. However, we know that we have designed a filter to meet their specific needs and could be used by other groups in the future. Through t-shirt sales, we collected $200 that we will donate to a charity that provides clean water for Malawi. This project has exposed us to hands-on engineering design and environmental techniques of the industry.